now that you know what a BalloonSat is and the kind of mission that we're going to do for remote sensing, which is imaging in disaster area, the question is, how do we actually control the camera shutter? We can't be on the BalloonSat. So how do we take, if we're imaging a disaster area, what we'd want to do is we want to take photos at specific intervals. Let's say every couple seconds. You can actually go to the store and buy cameras that do have this kind of feature, but we wouldn't necessarily want to put one of those cameras onto our BalloonSat. These cameras are going to have a lot of features that we don't need, such as if you have a digital camera, it has a screen so you can frame your shot or look at your pictures afterwards. But there's going to be no one on the BalloonSat to view the screen, so we don't need the screen. If you're taking a picture with one of these cameras, there's a button for you to press for the shutter, but no one's going to be there to physically press the button, so we don't need all those buttons. May not even need a case for these cameras that are going to go on the BalloonSat. So we can get rid of a lot of weight by getting rid of these things that are on commercial cameras. And why would we want to do that? Well, the smaller and lighter that you can make a satellite, the less expensive it is to put it up. For a BalloonSat, of course, it's pretty cheap, and this cost is not that important. But if you are trying to put a satellite into orbit, then that cost is very important, and you'd want to do as much as you could in order to reduce the size and reduce the weight of your satellite while still accomplishing the mission that you wanted to do. Another problem that we would have with commercial cameras is that they're not made to withstand the kinds of environmental conditions that the BalloonSat might experience. When you go up to 100,000 feet, the air temperature is down to about negative 51 degrees Fahrenheit or negative 46 degrees C. Most consumer cameras aren't made to operate at that kind of temperature. And you can also have increased amounts of radiation since the atmosphere is thinner. There's not as much atmosphere to protect you from radiation. And so the electronics have to be a little bit more hardened to withstand that. So this is all pointing us towards the fact that we probably want a customized camera for our BalloonSat in order to accomplish this mission. And like I said, no shutter button or anything like that. We're just going to trigger the shutter with a voltage signal instead. But we still want to have that same interval feature where we're just going to take a picture every few seconds. So in order to accomplish this, we can use an integrated circuit device or IC device that has a part number LM555, and this is a timer device. This device will produce a square wave. So if I were to plot voltage at the output of the 555 timer as a function of time, it would look something like this. And a portion of that voltage will be at some high voltage, there will be some low voltage, and we can use this to trigger the shutter. So if a high voltage will be a shutter trigger, then at this point in the square wave cycle, the shutter will go off, the camera will take a picture. When the output goes low, the camera will reset itself. Next high, camera will take another picture. Camera goes low, it'll reset itself, wait for the next picture. It goes high again, it'll take a picture again, and so on, as long as we have this signal going to the camera. Okay, so that's how we can use an integrated circuit device to create a trigger for our camera to take pictures for this mission.